Everyone, I'm Wendy. This is the final lecture of my intermediate statistics. Topic is full model and reduced model. By the way, I hope you subscribe my YouTube channel, Wendy. Okay, then you may see any topic whenever you need. So I recommend it. All right, let's see what the full model and reduced model for partial test hypothesis. Think about beta j and beta k equal to 0. The hypothesis, this one, to test whether two explanatory variables xj and xk are significant or not when they are p explanatory variables. A model that includes all p explanatory variables is called full model. You consider, say, 6, 7 explanatory variables, including all the explanatory variables, the model we called full model, FM. And the model reflecting the null hypothesis, this one, null hypothesis, in other words, excluding xj and xk, is called reduced model, okay, RM. Then, based on whether there is a significant difference, in other words, how large the difference in the regression sum of square, SSR, okay, between the reduced model and the full model. If it is very, big, large, then you have to reject this one, okay, because this hypothesis means xj and xk do not work in the model. The null hypothesis will either be rejected or not rejected. So how large significant difference or not? Now let's take an example. Let's say we are considering 5 explanatory variables and want to test hypothesis beta 1 equal beta 2 equal 0. In this case, the full model and the reduced model, full model, of course, there are 5 explanatory variables in the model, and the reduced model, reflecting this one, null hypothesis. So x1 and x2 is not excluded from the model. So yi equal to beta 0 star, beta 1 star, because it should be different value. So I get star. Beta 1 x3, okay, beta 2 star x4 plus beta 3 star x5. There is no x1 and x2. You understand the reduced model? Okay, reflecting the content of null hypothesis, respectively. Of course, the regression sum of the square, SSR, of a full model is greater than that of a reduced model because there are many. There are more explanatory variables in the full model. However, whether the null hypothesis H0 is rejected or not depends on how large the increase in the regression sum of squares, SSR, is when x1 and x2 are added to the reduced model, right? We studied the last lecture. Specifically, it is determined by the size or magnitude of SSR x3, x4, x5 given adding x1 and x2 regression sum of square, right? But what is a test statistic in this case? It is not easy. It is important. You have to use F statistic like this. The numerator is this one. SSR x1, x2 given x3, x4, x5 divided by its degrees of freedom. And the denominator is usually we use SSE, x1, x2, x3, x4, x5 full model divided by its degrees of freedom. Degrees of freedom is what? N minus 1 plus P, like this. P is number of explanatory variable. 1 is beta 0 intercept. So usually N minus 1 minus P is degrees of freedom of SSE. Okay, but it is difficult. What is this? The degrees of freedom, SSR, x1, x2, given x3, 4, 5, is the number of parameters in the full model. How many? 6. There are 6 parameters. Minus number of parameters in the reduced model. How many? 1, 2, 3, 4. 4. So 6 minus 4 is degrees of freedom. Okay? It's degrees of freedom. Remember this. No problem? All right, let's see example. Now, suppose we want to perform regression analysis of supervisors evaluation scores Y with 6 explanatory variables, x1, x2, x3, 4, 5, 6. And the data were collected from 30 employees. Okay? They are 30 data, 15, 15. Suppose we want to test whether the set of 4 variables, x2, 4, 5, 6, should be included in the model or not. So the null hypothesis is like this. Okay? 2, 4, 5, 6, or 0. In this case, the full model is full model beta 0 plus beta 1 x1 plus beta 6 x6 plus epsilon. And the reduced model y equal beta 0 star beta 1 star x1 plus beta 3 star x3 plus epsilon. Okay? Then SSR what? x1 reduced model, x1, x3 given, adding x2, 4, 5, 6. Then what is SSR increase? That is SSR full model minus SSR reduced model. It is very simple to calculate. I think there is no way, no software program to perform your partial hypothesis test. Okay, then it is simple. For this model, there is SSR 3082.1587. For this model, X1, X3, 3042.3177. Okay, so you get 39.841. This is what? Numerator of test statistic. And the SSE full model is 1214.8079. So that F statistic gonna be here 39.841 divided by what? Degrees of freedom. How many parameters here? 7. How many parameters here? 3. So degrees of freedom of this part, SSR part, numerator is 4. And this one, bottom, denominator, is degrees of freedom is 30 minus 1 plus how many? 6. So it's going to be 23 degrees of freedom. So you have to calculate this one in hand. Okay? So F value is 0.1886. The F value 1886 is much smaller than F value of 1.45 at the F value, F distribution with degrees of freedom what? Degrees of freedom 427. F 427 distribution. The tailed area is 0.025, a small area, and the value is 1.45. Understand that? This one? F value 1.45 at alpha equal to 0.025. Okay? But you get the test statistic, value of test statistic, 0. I don't know where, but here, 0.1886. So you cannot reject null hypothesis, right? Right? Okay. All right. I think you may understand this simple example. Oh, by the way, if you want to test the hypothesis, say beta 1 plus beta 3 equal to 1, okay? 1 or 0.5, some value, any complicated thing. Then how to make reduced model, okay? Beta 3 equal to 1 minus beta 1. So your reduced model, beta 0 star plus beta 1 x1 plus beta 2 star, okay, let me take it start, x2 plus what? 1 minus beta 1 x 3, okay? Beta 3, because beta 3 is 1 minus beta 1, so you include this result instead of beta 3 plus beta 4, beta 5, beta 6, something like that. And you may calculate here, beta 1 star. You may calculate, you may summarize, simplify this equation, and you may count the number of parameters in the reduced model. Okay? Yeah, this is also sometimes necessary to be used. All right, thank you so much. I want to prepare the appendix after this lecture. Thank you so much again. Bye.